So looking at the calendar, again, the Thursday will be a quiz. It'll be posted in Schoology. It might even be a Schoology quiz for you online people. So it'll be a daily grade, not a test grade. It'll count more than most of the other daily grades. But this unit is short and sweet with calculator, so you should be okay. All right, vectors, day 2 of 2. Let's get some vectors to work with. So just some example vectors. Let's let u be 2, -3. V is -4, 1. And w can be 3, 2. Let's first talk about multiplication of vectors. Multiplication of vectors. Because usually we think multiplying, that's easy, right? 3 times 5 is 15. I know how to multiply. But with vectors, kind of like with matrices, there's more than one way to multiply. It's maybe as weird as that sounds. There's a scalar product. This we've done before. Like this is what we did yesterday. You're multiplying a vector by a scalar. A scalar is basically a fancy word for not a vector. A scalar has magnitude but not direction. It's another way to say that. So 3 times u is, I just multiply both of them by 3. 6, -9. That's pretty easy. That's what we normally think of as multiplication. That's the kind of multiplication we did yesterday. And we got a vector answer. A second type of multiplication is called a dot product. And it uses the little dot, right? This is why multiplication has like a bunch of different symbols, right? You can just stick the number next to it. That means multiply. You can put a dot in between them, like u dot v. And in numbers, they all kind of mean the same thing. In vectors, the symbols have specific meanings. And so this gets a little bit confusing because you're used to thinking 3 next to u is the same as 3 dot u. And with numbers it is, but with vectors it's not. Here's how we do u dot v. So 2, -3, dotted with -4, 1. And it's easier to do it than to explain it. The explanation is multiply the x's, multiply the y's, and add them together. So that maybe is the weird part. Like with the dot product, it turns out there's 2 multiplications. So 2 times -4. And the other multiplication, the y stuff, -3 times 1. And we add them together. So multiply the x's, multiply the y's, and add them together. And if it was a 3-dimensional vector, you would multiply the z's and add them in as well. So -8 plus -3, our answer is -11. That's a dot product. So dot product involves like 3 different operations, 2 multiplies and then an add. Multiply the x's, multiply the y's, add them together. All right, not hard, but you try one. You try v dot w. Again, v and w are still listed at the top up there. I'm not even pausing the video. It's because I think you can do it quickly. That's another great example of places where some of you are going to skip a lot of steps, and that's okay, as long as you can come up with the right answer without messing anything up. Negative 12 plus 2 is negative 10. And so yes, you can do that in your head. Negative 12 plus 2 is negative 10. And that's fine, just be careful because that's 3 steps in your head. I don't want you to mess it up. So that's dot product. The last type of vector multiplying is called a cross product. And the symbol for this one is the little X, like the first symbol you used or what you learned was multiplying. Like my kids are in grade school, so I'm sort of relearning math as they go through elementary school now.
Your answer isn't right, but your work with the wrong answer is right.
So this is like when you first learned multiplication, it was the little X symbol. You didn't know the dot or just sit the number next to each other. You learned the X thing. The trouble is this is the most complicated kind of vector multiplication. So we're just going to say this is not for us. So I wanted you to see it. That way if you take some math class later and you see a cross product, it won't be, it'll still be completely foreign because I'm not even telling you what it is. But you'll know it's some sort of crazy multiplication. And at least now you understand that there are 3 different types of vector multiplication. And it sort of explains why there's 3 different symbols for multiplying just regular numbers. Right? You can do 3 times 5. You can do 3.5. Or you could just stick 3 and 5 next to each other, and that would all mean 15. But in vector land, those are different things. I'd have to rethink how to do it. It comes up a lot in physics. Work equals force cross with distance, I think. Torque equals force cross with radius. Like, it comes up in physics a lot, but it may not even come up in the physics you do, so you still don't have to worry about it. All right, so that's enough about cross product, since you may not do anything with it in high school ever, but wanted you to at least understand that there's yet another way to multiply with vectors. All right, last thing for the entire unit. We'll review tomorrow and quiz test assignment Thursday. Angle between vectors. This is a formula that we will give you when you need it. The cosine of the angle between vectors is equal to u dot v. So the dot product over the length of u times the length of v. And again, we'll give you all of those things. In words, not that you would memorize the words, not that you're going to memorize anything. It's the dot product over the product of lengths. Right, the 2 bars means find the length of u and the length of v. So finding the angle between 2 vectors is a lengthy process, because you got to find a dot product, you got to find 2 lengths, you got to put all that together, and then you would have to inverse cosine all of that. So a lot of steps, but that's why we will give you the formula. So, example, let's find the angle between u and v. I'll write them again. 2, negative 3, and v is negative 4, 1. I want the angle between those 2 vectors. To me, the easiest way to keep up with this is definitely not a spot to skip steps and try to do it all on the calculator and just put it all together and write an answer. To me, it's best to slow down, write out all the pieces, and then put it together. Right, there's the three pieces that I need. Let's find all of those. Maybe I skip a bunch of steps finding those, and then I'll put it together to find the angle. All right, U dot V. Again, if you're feeling adventurous and you want to skip steps, that would be, we already did this, but -8 minus 3. Oh, I can't help but show a little bit here. It would be -11. Right? X times X is -8. Y times Y is -3. Combine them together, we get -11. The length of U, so that would be the square root of a squared plus b squared. And again, I'm going to be kind of lazy and leave off the negative, just because I know if I go to the calculator, if I mess up parentheses, rather than worry about it, I just leave it off, because I know it's not going to matter when I square it. 4 plus 9 is 13. And rather than get a decimal for that I have to keep up with, just leave it as square root of 13, because that's going to be easier to put in the calculator than 3 point whatever. So leave it as square root of 13. Same thing with whatever we get for V here. 4 squared plus 1 squared. 16 plus 1 is 17. That's 4 point something, but I don't really care about the 4 point something. So I got my pieces now. I can put them all together. Cosine of the angle. Thank you. Yes, she is. Cosine of the angle is the dot product over the product of the lengths, which means I need to inverse cosine all of that stuff. So inverse cosine. I'm going to do a fraction bar so I don't mess up all the parentheses. -11, square root of 13, square root of 17. I think I want to be in degrees because I'm going to check my answer in a minute. So inverse cosine of the dot product over the product of the lengths. 137.726 degrees. So again, the formula is a little bit tricky. It's got a lot of pieces to it, but it will always be given to you. So it's just a matter of, finding the pieces, putting it in the calculator the right way, being careful. I do want to show you a way to check that answer. Let's graph these two vectors and see if the angle looks like 137. So 2, -3, that would be over 2 and down 3. And reasonably to scale would make our life a little better. So there's 2, -3. -4, 1 would be back 4. 1, 2, 3, 4. And up 1. So about right there. And so our calculations tell us that is about 138 degrees. I mean, if I really wanted to check it, I could put it on graph paper and get a protractor out. I don't want to do all that, but it's certainly bigger than 90, so I'm buying that that's an answer. So you don't have to do that, but it does provide at least a little bit of a check on your answer. All right, that's a lot of steps, so you need to try one. Last example, I want you to find the angle between V and W. V was -4, 1. W was 3, 2. So find the three pieces, put them all together, inverse cosine, see if you can do it. So we find all the pieces. Dot product we already found. Length of V length of W, put it all together, inverse cosine, 132.274. And again, if you wanted to check, V is negative 4.1, W is 3.2, and so that angle is 132. Again, is that exactly 132? Who knows, but it's in the ballpark, so I feel good about my answer. All right, there's one last set of questions that we sometimes ask, and that is parallel, perpendicular, or neither. Are two vectors parallel, perpendicular, or neither? Well, if two vectors are parallel, what do you think the angle between them is? Let's see. So there's two parallel vectors. If I put their starting points at the same spot, what would the angle between those two vectors be? What's that? Somebody said it, I think. Pardon? 0. What about if it's pointing the other way? What would the angle between those two vectors be? If I put their starting points at the same spot, what would that angle be? So 0 would be like where they're like right on top of each other. If one's pointing one way and one's pointing exactly the opposite, 180. So if you get 0 or 180, you're parallel. Perpendicular, that's an easy one. What angle would we find there? 90. And neither just means not 0, 180, or 90. So when we ask parallel, perpendicular, or neither, it's a sneaky way of getting you to find the angle. And then once you know the angle, you can answer the question. So 8, 9, and 10 on worksheet 4, the question is, are they parallel, perpendicular, or neither? That's really just code words for find the angle between them and then figure out if it's 0, 90, or 180, or none of the above. Formula is given at the top. It's also given on the quiz on Thursday. We don't even have a review worksheet, so I'll do some warm-ups tomorrow. I'll answer questions from this tomorrow. Really could test tomorrow, but then we'd be doing something new the day before break. Nobody wants to do that, so we'll review tomorrow, but it won't be much, and then we'll take the assignment on Thursday. So